Hello. This is a great crowd. I love this. Welcome. How's New Relic going so far? How's reInvent going so far? I'm sorry. I need more sleep is what I need. My name's Lee Atchison. I'm the Senior Director of Strategic Architecture at New Relic, and I'm also the head of our evangelism team. And I've been with New Relic for about 6 years. New Relic does application visibility, application performance monitoring for both on-prem and cloud-based applications, and helps you keep your application visible at scale. I've been at New Relic for about 6 years, and before that I spent 7 years at Amazon, including working at AWS for a few years. Who's here familiar with Elastic Beanstalk, that service? I started that group that built that service. That kind of dates when I started with AWS. So I have a lot of experience with building highly scaled, high availability applications. And I want to talk about monitoring those applications and how you keep your applications running at scale. So first I want to start with a story. And I want you to tell me if this story sounds familiar. It's the day of the big game. You invited a dozen of your closest friends over to watch the big game on your brand new 50-inch Ultramax Super Deluxe TV. You've got your beer laid out, you got your snacks laid out, everything's ready to go. The game's about to start when suddenly the power goes out. Lights go off. The game for you and your friends is over. Well, not quite completely for everybody, because your friends, they go to somebody else's house and watch the game, but it's over for you. And you're sitting there wondering what happened to your big day. This was your big day, the day that you wanted to show off to your friends your brand new TV. You wanted to show off. It was your big day, and it didn't work. So pretty upset, you call up the power company, you ask what happened, and they were very unsympathetic. After all, you had power most of the time, right? Your application works most of the time. Why are you complaining? You're complaining because your customers don't care if your application works most of the time. They care whether it works when they need it to work. And that's what availability is about. That's what scaling is all about. So keeping enterprise applications at scale requires a number of steps. And I'm going to talk about each of these in turn. But first I want to start with visibility. And I'm going to start by describing a true story. This is a story of a conversation among ops engineers that I overheard at a different company. I won't say which company it was, but tell me if you hear any truth in this for your environments and your operations teams. We were wondering how changing a setting in our MySQL database might impact our performance. But we were worried that the change may cause our production database to fail. So far, so good. Since we didn't want to bring down production, we decided to make the change to our backup replica database instead. After all, it wasn't being used for anything at the moment. Of course, the inevitable happens, and this absolutely was a true story. But availability problems can be more subtle than do you truly have backup systems in place? It can be much more subtle than that. For example, this is a highly stylized example of a microservice-based application, and let's just assume it's an e-commerce site with a mobile phone front end and a bunch of back-end services and some databases. Now Fred comes in and he does a transaction, goes to the mobile app, goes all the way to the database, everything works fine, comes back, 300 milliseconds later, his transaction's complete, he's a happy camper. But now Beth comes through and does the same thing, except this time there's a database problem of some sort. Slows down the transaction. Her experience is a lot slower. Still worked, but it took a couple of seconds. She's not as happy. Her experience wasn't as positive. And for her, your site failed. Your site it didn't do what it was supposed to do. It didn't meet her expectations. But so often, when we look at this, what we do is we say, hey, our site's working fine. On average, we're getting pretty good performance. that's not the way to think about how your application performance works. It doesn't matter what the average performance of your application is. It matters what individual users' expectations of that performance is and how the application works for those individual users. So this doesn't help. What you need is every transaction, every detail about every transaction, and every point within your system. You need instrumentation everywhere in order to truly understand what your application is doing. And in fact, this generates so much data that in many of the applications that we monitor, we find that the performance data that we collect actually significantly outstrips the business data of the application itself. But that's important because without this performance data, you can't truly tell whether your customers are having a good experience or not. And it's data of all different types of performance data of all different types. It's server data, it's application performance monitoring data. It's data about how the user experience of the customer is actually, what's their real user experience that's going on, and it's how your business is performing. So it doesn't matter if your customer experience is great if your business needs aren't being met. All of this, though, creates a big data problem. And handling this data is important, and having a tool that can process and analyze this much data is critical. Visibility is so important because without it, your engineers start blaming each other. Problem must be someone else's fault. Your expectations, which are high for your application's performance, just aren't met anymore. You need to know what happens when a problem occurs. You can't know what happened if you can't visualize what your app is actually doing. So here's a simple application. It's a bunch of servers, virtualized servers running on operating systems with application software running on top of it. And imagine all that in a cloud-based set of servers. And then you have mobile and browser applications running on top of it. And AWS provides CloudWatch, which gives you a lot of the low-level monitoring capabilities just to keep the basic server monitoring working. But that's about all they provide. You also need to know how the server is performing. You need to understand how your infrastructure that you're building your application on is running. You need to know how your application is running. You need to know how your mobile apps are running as well. All of this together builds a picture of how your application is performing, and all of this data is what you need in order to keep your application running at scale. Because when your application fails, finger pointing does happen, app failures cost your company money and creates unhappy customers, and of course, unhappy customers tell other people about problems. And this is never what your customers expect. That's visibility. Visibility is important, but you also need technologies to help keep your applications running at the scale you need them to run. That's where the cloud comes in, but not just the cloud, the dynamic cloud. And the dynamic cloud helps you build applications in such a way that you can deal with scaling issues on the fly as they occur. So what do I mean by the dynamic cloud? Well, there are two main ways that enterprise applications today make use of the cloud. Here's what I call the better data center approach to using the cloud, and there's using the cloud in a more dynamic fashion. I'll talk briefly about each of these. The better data center approach, this is characterized by resources within your application, whether they are servers or whatever it is, are allocated to specific uses, just like they're in your data center. You create servers, you assign them to applications. Those applications are the permanent assignment. They're allocated, they're static, they're specific to that application need. Of course, the provisioning process of those servers is faster, but the lifetime of the resources and the components that you create is relatively long. Usually you measure the lifetime in weeks or months or years versus anything shorter than that. And so traditional capacity planning is still important. You need to figure out what your traffic needs are on any given day and make sure you have the capacity in place to handle that need. You still have to do traditional capacity planning in order to keep your application working at whatever scale is necessary on your biggest day, whatever that biggest day is. So why would you use the cloud in this model? Well, it still provides benefits. You can still add new capacity easier. You can build in redundancy, which gives you higher availability and give you the capacity where in the world you really need that capacity to be for compliance or other reasons. And that's all great, but that's pretty much about it. It doesn't really help you with scaling. It doesn't help you with capacity planning. It doesn't help you with making sure that your application is ready to go on the big days, like Black Friday, like Cyber Monday. When you need it, it doesn't help you figure that out. The dynamic cloud helps you more in that environment. And what do I mean by the dynamic cloud and dynamic environment? When the dynamic cloud really is characterized by applications that use only the resources they need at that given moment in time. And they allocate and deallocate the resources on the fly dynamically, and the allocation and deallocation of those resources is an integral part of the application architecture itself. Resources are allocated, they're consumed, and they're deallocated, and all of that is under the control of the application and the application environment. So I want to give you an example of what I mean by this. We're a SaaS company, and we take data from all of our customers, and we can do some analysis of some of that data in a very generic way. And we did this with Docker. This is about a year ago when we first did this. And we wanted to get the answer to a real simple question. How long does an average Docker container run for? Well, we expected it to be a nice, pretty bell curve with center at some magic point. We didn't know what that center point was, but we expected a regular bell curve. But we didn't get that. What we got was a graph that looks a lot like this. So at the time, our longest running Docker container that we were monitoring had been running for well over 2 years, which is a very long time. But the vast majority of Docker containers were running for less than 1 hour. Had a lifetime, a total lifespan of less than 1 hour. And we thought that was interesting. We didn't expect that. So we took that 1 hour time interval, got rid of all the rest of the data, and just expanded that 1 hour time interval, and we got this. Turns out that over 11% of all Docker containers that we monitor with New Relic run for less than 60 seconds. 11% of all Docker containers run for less than 60 seconds. And just to be clear, we're talking about Docker containers that are really performing a business function here. We're not talking about Docker containers that failed at startup and terminate right away. We've got rid of all of those bad results from this data. These are Docker containers that have started up, performed some business function that was important to some application somewhere, and terminated in less than 60 seconds. 11% of all Docker containers ran for less than 60 seconds. This is what I mean by the dynamic cloud. This is resource allocation on the fly for a particular purpose, for whatever the business need is at the time, and then free that resource when you no longer need it. And this same sort of model applies to many other things, especially within the cloud. Obviously, EC2 autoscaling is a big example of how this might work. Docker is a good example. We've seen customers who use AWS queues, SQS queues, by creating the queue itself on the fly, making use of it for some series of business purposes, and then deleting the queue when they're done with it, and doing that at whatever scale they need. We're talking about the queue itself, not just what goes on the queue, but the queue itself being created and destroyed on the fly as it's needed. And of course, here, load balancing, dynamic routing. Lots of different places within the cloud you can see this in use, and where you can see resources that can be used and consumed and manage the resource allocation process themselves, managed by the application within the application use. The dynamic cloud allows building applications faster and better that can scale and provide the scaling that your application needs faster and better. The way you've built applications in the past is very different in the cloud, with these dynamic technologies than it has been any other time in the past. And certainly, we know about EC2, we know about Docker. Those are great technologies, and they're showed you how you can imagine how they're used for resources for this sort of dynamic technology. But of course, now there's Lambda, serverless, functions as a service that perform that same type of resource allocation. Lambda functions are highly dynamic, highly incredibly scalable way of processing data, doing compute on the fly as necessary, where the compute function itself is allocated basically on demand as that compute resource is needed at whatever scale is necessary. You're taking from a common pool of resources within AWS for your own particular application to manage at whatever scale you need, and you don't have to worry about that. This is truly what the dynamic cloud is all about. The dynamic cloud, it does allow easier scaling, as I talked about, but it also allows you to build applications faster and make changes faster. You can use a dynamic cloud to deploy new applications, to launch an application using a new set of resources and terminate the old one when it's done as a method of doing deployments. Using the dynamic cloud, you can very easily do staging environments and development environments, et cetera. All of those things help build applications faster, and all of those things together results in higher availability for your applications. This is all great, but how do you monitor a dynamic application? How do you know what a dynamic application is doing? Let's take a look again at that same application I did before, except this one's a little bit fancier, right? It's got some services involved, but it's basically the same sort of application we had before. And we still have traditional low-level AWS cloud monitoring that's going on as you normally expect it to. That's all great. You can still imagine how something like New Relic can be used for application monitoring and infrastructure monitoring and browser mobile monitoring, just like it does in a traditional static application. And that level of monitoring covers the vast majority of a dynamic application. But there's this new piece that exists in a dynamic application. It's the provisioning process for all these dynamic resources. How do you monitor that? How do you keep track of that? How do you monitor resources that come into existence 1 minute and disappear the next minute? How do you monitor something that was there 10 minutes ago but isn't here now? Remember the Docker data. And it turns out that monitoring the dynamic cloud really is very different than monitoring a traditional static application, because you still have to monitor the individual static cloud components itself, just like you do with a regular application. You still have to monitor the application, you have to monitor the servers, you have to do all the things you normally do, but you also have to track the life cycle of the components, of the resources that are being in use. Because it matters not only that a resource ran, it matters when it ran in order to be able to diagnose problems and know what's going on. And knowing which resources were used at a time when a problem occurred is critical for diagnosing a problem in your application. It used to be the world of operations was well contained and well controlled. Your operations team managed racks of servers, and those servers had serial numbers and heck, even names in some cases. And you had spreadsheets of your servers, and you knew exactly what applications were running in each one and what software was running in each one. And it was a job of someone to manage that, and they controlled that data like it was golden, because that's the way the world was. You don't change anything unless you go through the process to make a change. But that's not the way the world works anymore. Resources your application are running on are dynamic, they come and go, they move often, they move consistently, they move in such a way that you can no longer keep track of them on spreadsheets. The exact names and resources that are available are no longer relevant. The resources come and go dynamically, and this dynamic world is a very different way of working than we've worked with in the past. This is a new environment, changed environment. It truly does allow greater growth in applications and more scalability within applications. And that's the dynamic cloud. And that's what the dynamic cloud can do for you. But that's all great, that's all fine, but that's assuming that your application is running in a cloud environment in the first place. That assumes you've migrated to the cloud. Many of you in this room have, many of you have not. Many of you are in the process of doing it. Many of you have succeeded in doing that, migrating to the cloud. Many of you have tried and failed migrations to the cloud. It's very easy to get into a trap of saying, yeah, we're going to move this application to the cloud, we're going to move it, we've got all these advantages we're going to get, it's going to save us money, it's going to make it more scalable, and everything's going to be golden once we get to the cloud. But reality sets in and you find that, well, maybe it really wasn't as cheap as you expected it to because you didn't make the right assumptions on how you built your application. And your costs go out of control, your problems start occurring, your schedules start falling apart. Ultimately, you get to the point where it's like, why do we move to the cloud? Why did this help? And a lot of companies who go through this process, they fail, and they'll take a step back, and they'll say, why do we even consider moving to the cloud? When in reality, they should have moved to the cloud. They just should have moved to the cloud in a more controlled way, in a way that was more likely to be successful and more likely to result in a successful migration. And so, you can move most applications to the cloud, but you have to move in a much more controlled way and learn as you go and measure everything as you migrate to the cloud. So I've gone around and talked to a lot of customers who have been both successful and unsuccessful in cloud migrations. And I've created a maturity curve, if you will, a set of levels, set of steps that every company that moves to the cloud ultimately must go through this maturity process, or a process very similar to this, in order for them to have a successful migration to the cloud. And every company in this room is at some point on this step, on this ladder. They may be down at the bottom just starting a migration. They may be very sophisticated near the top, but everyone sits on the scale, on this maturity curve somewhere. And I want to go through each of these levels. Let's start with experiment. This is the first stage that companies go through. This is a stage where, I would say most companies have already gone to the stage where there's a group, there's some development team or a couple of development teams within a company, and they're interested in using the cloud for something within, trying to solve some problem that they're dealing with within their space of control. But the company itself doesn't really know what's going on. They might just be using the cloud for some really simple things. They might be doing it under the covers. They might be using it only for staging. Whatever it is, they're just learning about the cloud. Nothing formal, nothing policy-wise within the company. It's just, let's see what this cloud thing helps to do. Let's see what we can do with this cloud. These are teams that will come as individual teams versus an entire company to a conference like this to learn what's going on. But they won't be representing the company because the company itself doesn't really know what they want to do with the cloud. These people will be the leaders in the migration to the cloud for the rest of the company as time goes on. But right now, they're just the outcasts, the learners, the ones that are trying to do things in a different way. Second step is policies. This is a place where the company makes a decision that, yes, the cloud is important to us. Yes, we do need to move to the cloud, and we're going to do it using this process. This is where the company starts thinking about policies for what it's going to take to use the cloud. Can we use the cloud for this class of application because it's secure enough? Or can we only use it for this class of applications because these things have to run someplace else for whatever reasons? How do you deal with security? How do you deal with finance? How do you deal with all the different aspects within a company? And this is the point where the entire company is involved in trying to figure out what the strategy is for why we're moving to the cloud, and basically what we want to accomplish with the cloud, and what the restrictions are on what we can do within this migration. This is a critical evolution point because as the company creates these policies, they're setting the tone for the rest of the migration that's yet to come. This is the trust stage. Can we trust what the cloud offers? Can we afford to move our applications to the cloud? Next step is enablement. This is primarily servers, but other things as well. This is basically when lift and shift occurs. This is when a company says, yes, we're using the cloud. Here's an application. We want to move this application from here to the cloud, and everything's fine. And we're not going to make any changes to the application. The application's fine. We're just going to move it to run in the cloud as a cloud-based data center. And this is actually a point where a lot of migrations fail. Because what happens is companies do a traditional lift to shift to the cloud, and they don't think about any sort of optimizations or any sort of improvements that go on. So all they're doing is they're taking an application that was running on 50 servers of X size and moving it over to run on 50 cloud servers of X size, not making any other changes in that. And what happens is, rather than running on 50 servers running in your own data center relatively inexpensively, you're running on 50 cloud servers that provide all sorts of other advantages, such as dynamic creation and deployment and that sort of thing. But they're not taking advantage of those things, but they're paying for them. So often companies will see at this point in time that, oh, it's too expensive to run in the cloud. We can't make it work. This is one of the points where companies fail at migrations because they fail to take advantage of the features of the cloud, yet they're looking at the cost of the cloud and seeing that it's not satisfactory. Independently, companies at about this stage also start making a decision about usage of SaaS and SaaS applications within their production applications. Traditionally, large enterprises tended to stay away from SaaS applications, but slowly, little by little, they started accepting SaaS applications as being an acceptable way of doing business. And this is a stage during the cloud journey that these companies start seeing the value of SaaS. Just like they see the value of the cloud, they start seeing the value of SaaS-based applications. Next step is value-added services. So, great, we've taken our application, we've lifted and shifted to the cloud. One of the servers was running let's say a Postgres database, and we moved that Postgres database to a server in the cloud, and everything is stable and everything's fine. But it's so easy to say, okay, that's fine, but the cloud has managed versions of some of those services. We're using a Postgres database. Let's use the RDS version of that database. Let the cloud provider manage the database for us rather than us managing it ourselves. Or we're using Elastic Cache. Let's use a managed Elastic Cache service instead of one that we build ourselves, or a Redis service, or whatever other service you require. This is where you start seeing the advantages of the cloud start taking effect and to start counteracting some of those cost issues. Start using services like Beanstalk or Simple Email Service, SQS, Elasticsearch, RDS. Those services start becoming used, and the value of those services in helping you manage your applications increase. So once you've done that, now you start thinking about unique services. So it's fine that we're using these managed services, but we're still using the same software that we were using on-prem. We're just using a managed version. We're still using Postgres. Same interface I had before, same data set, everything's exactly the same. We just use a managed version. But in this stage, companies start saying, okay, well, that's great, but DynamoDB has some neat scaling advantages that we can take advantage of. Let's start using DynamoDB. Let's start building that into our application. Let's start using Lambda or Kinesis. Let's start using Simple Workflow Service. Bunch of different services that have no counterpoints or no precise counterpoints back on-prem. These are cloud native services that are unique to the cloud, that have significant value to you to be able to use in the cloud. But by using these services, you've now committed to the cloud. You can no longer take this application that's using these services and easily move it back to your own data center. Or for that matter, you can't easily move it to another cloud provider, because the way DynamoDB works in AWS is different than the equivalent service works in Azure, for example. So this is a point of commitment. This is when you're committing your application to running in the cloud, and you're committing to running in a specific cloud provider. But it's also the point when you start seeing the advantages of the dynamic cloud much deeper than you were before. You start seeing the advantages and the real advantages of the cloud, both cost and the advantages that you get from using the services, really start coming to mind. Companies that get to this level are the ones who are really, truly become successful in their cloud migrations. Last step is mandate. Everything's working fine up to this point, but now you get to the point where you say, okay, we love the cloud is great, we're moving everything to the cloud. Why do I sell my own data center? Why do I want to be in a data center business? Let's move everything to the cloud. And it used to be that very few companies even considered doing this. It used to be, even just a year or two ago, that most companies extended their data centers in the cloud, but didn't consider getting rid of their own data centers. But more and more in the last couple of years, I've been seeing companies I've been talking to truly have a plan to make this happen. So true enterprises that were never in the cloud before, they're moving to the cloud now, are making plans to get rid of their own data centers completely. And that's a new trend that's been starting within the last year or two, I've noticed. So that's the last step. Why do we need our own data centers? Different companies go through these at different speeds, but I bet you everyone in this room, the company that they're in, can find where they sit really on this maturity curve. And this is the maturity curve that the enterprise itself goes through. There's a very similar set of maturity that individual applications within the company also go through. They're basically the same steps, maybe relabeled a little bit. But applications go through the same set of steps, but they go through at a different speed than the company itself. Some applications may move faster than the company through their maturity, some may move slower. That allows you to create a curve, or a matrix that shows corporate maturity up the side and application maturity along the right-hand side. And there you see the first steps in cloud migration in the experimental stage. But the first thing that a company will do is they'll start moving internal applications. These internal applications will be applications that are not customer-facing, may or may not be important internally, but they're easy to move. They're less critical to move. The risk of failure is low. And so that'll occur very early in the corporate maturity. But since they are less risky, they'll very, very quickly adopt extensively into the cloud itself, and the application itself will make extensive use of the cloud. It will become a very mature cloud application, but not the corporation itself. The application will become mature much faster than the corporation itself. And then you move on to new applications. And new applications will typically be a little bit less aggressive, if you will, in adopting cloud technologies within the application. And you'll move these applications a little bit later in your corporate maturity. And then a little bit later will be application rewrites, where they'll be a little less conservative, or a little bit more conservative again on the amount that they make use of the cloud, and happen a little bit later in the corporate adoption. And finally, it's critical applications, which may never move to the cloud, but if you end up ultimately getting to the point where you're going to mandate cloud usage, you will move them. But when you move them, you're going to be very conservative about how you move them. You might only do simple lift and shifts. You might not do anything more complicated than that. You might not want to trust anything more complicated than that. And that's all fine. You can put where services within the cloud provider like AWS kind of fit within this curve too. You see Amazon S3 is a service that's very much used in experimental stages, and then further up the line is EC2. And things like Lambda and Kinesis are much later and much more for higher maturity applications and higher maturity companies before they'll start using those services. And that's all fine. And what you end up with is there ends up being this sweet spot where both applications and companies will very quickly get to a certain level of maturity, but once they reach that level, they'll very slowly move beyond. So get to this magic sweet spot, if you will, And this is where most companies and most applications will tend to migrate towards, or will tend to stick around there. And it turns out that that's where the most common AWS services happen to be as well. EC2, RDS are some of the most common services. And they're in the middle of the sweet spot. So that's all great, but I'm an enterprise, I want to move to the cloud, I want to migrate to the cloud. How can I be successful to make that happen? All that data is good, but what can I do to be successful? I talk about 5 steps in being successful, strategy to be successful. First is understand your culture. Moving to the cloud is more of a cultural change than it is a technical change. Understand your needs, create a solid plan for moving to the cloud, and then drive your cultural changes to match those needs. You have to make cultural changes to your company in order to be able to move and migrate to the cloud successfully. And most importantly, monitor your adoption. Let me talk about that one in particular a little bit more. A lot of companies we talk to say, yeah, this is great. We know we need more visibility in our applications, and that's great. We're going to move to the cloud, and then once we move to the cloud, then we'll add monitoring in order to get visibility to our applications. But we'll wait till after we move it to the cloud. And what I say is no, you want to start monitoring your applications before you move to the cloud, because you want to use the visibility that the monitoring gives you to your applications to create a baseline of how your application is performing and determine steady state how the application is actually performing. Then, during the migration, you can use that steady state. You can use that steady state. Here we go. Cloud, sorry, this got a little messed up here. You can use that steady state to see what variations occur while you're migrating to the cloud. You can see what things change during the migration, and any deviations from steady state, any deviations from what it was pre-migration is usually a good indication of a potential problem that's occurring. So you need to understand and solve all deviations from steady state before you can truly understand how your application is performing, and only then can you be successful to move forward and complete your migration. You want to continue monitoring after the migration is complete, because now you're running on an infrastructure that's outside of your control. If you're having a problem with your application, how do you know whether it's an AWS problem or if it's a problem with your application unless you're monitoring your application and monitoring the infrastructure to know how it's performing? So before, during, and after migration, all 3 phases. You want to have visibility how your application works at all 3 phases in the migration in order to have a successful migration. So that's the last step, migration. All 3 of these are important, and underlying all 3 of these is monitoring your application and your infrastructure. You know, it used to be not that long ago that all you needed to do to make sure your application was performing was to monitor your servers. You look at CPU and memory utilization. As long as CPU was relatively flat and memory utilization was relatively straight, your application was fine. If you started to leak memory a little bit or a CPU started going out of bounds, that'd be an indication a problem occurred. But that model doesn't work anymore. With highly dynamic applications that are highly scalable and highly dependent on how the environment is working, that level of real simple monitoring isn't appropriate anymore. You need a full-scale monitoring, top to bottom of your entire application stack, including the provisioning part, in order to truly understand how your dynamic applications are performing in order to avoid availability problems. The world is definitely changing, and the way of traditional data centers and even traditional use of cloud data centers is changing. And the dynamic cloud really is making things better, but different than the way it was before. The way you've done things in the past just won't work in the future anymore. So I'm very happy to have a special guest here, Mark Kelly, who is the Director of Cloud Infrastructure and Service Architecture at Scripps Network. one of our customers is here, and we're going to have a little Q&A session about his experience using New Relic and migrating to the cloud. Mark,
Thank you, Lee.
thanks for coming.
Thank you. Glad to
Pull
be
up a
here.
couple seats here.
All right. We're going to do this. Oh, look at this.
Move over here a little bit more. Okay, so Mark, why don't you tell me, first of all, I know what Script Network is, but I don't think most people know what Scripts Network is. What do you do?
That's true, Lee. I mean, when I say the name Scripts Networks, most people out there probably do not know what we are. But we are the leading provider of home, food, and travel content on your TV, the web, and emerging platforms. So what does that really mean? If I say some names in our portfolio, HGTV, Food Network, Cooking Channel, Travel Channel, DIY, and Great American Country, now you probably know who we are. If not, I'll guarantee you that your wife, your mom, or your sister does know who we are.
Great. So you've obviously started down a cloud journey now. Can you tell me a little bit about how that cloud journey got started? Why did you start that journey?
So our journey kind of started with some of the challenges you've been kind of identifying in here. We were strapped with budgets, reliability of hardware, purchasing hardware, getting it provisioned, maintaining it, and the business customers at the time really didn't know, what that process looked like. They just knew everything was slow. They needed things to get faster, needed to get better. That was when we had the opportunity to actually engage the cloud and move things forward.
So you chose AWS specifically. Mm-hmm. How was that decision made?
So we started pretty much with your exploratory process here. You kind of explore what's going on. We tried it in a bunch of different cloud providers out there. This was about between 5 and 6 years ago, so we've been at this a few years now. When we looked at all these providers, it was really a culture thing for us. We were looking at people that could help offset what we were doing or what we needed to do with the infrastructure management so that we could put our engineers focusing on creating value for the business. We wanted to move things forward much faster. We were in a position where we were competing with startups out there, and we're being a big enterprise. Those startups don't have the same challenges that we do. They want to spin up a stack, they want to do development, they just do it and go. They don't have to go get business buy-in or allocate budgets, provision hardware, and do all of that, those interesting problems. So they just do it instantly. We needed to get into that. So we found the partner that actually allowed us to move that way. And AWS ended up being the best bet for us at that time.
So this was a few years ago you started this process. Yeah. Now, when did you realize that you needed visibility in your applications to make the migration succeed?
We realized that pretty much right off the bat. We were composed of a bunch of different monitoring apps. I would say it was well over 50 different monitoring apps for, it might be one solution to monitor each application. We had so many monitoring tools that it was practically impossible to manage all of them. So we thought, as we approach this cloud, we're going to consolidate and we're going to come up with a monitoring suite and actually do it in real time. Make sure everything is at least instrumented for those monitoring tools so that we've got it out there. We can have all the data available as we need it and keep that visibility for all the applications going forward.
So just tell a little bit more what some of the problems you had by having multiple tools and what were some very...
Some of the problems that get created with having multiple tools are your operational problems. You don't have enough people to learn 50 to 100 different tools. To have to train people on these different tools and then they only use them once or once a year, you're retraining them every time. If I've only got a handset of tools and they've only got to train them on them and they're using them on a regular basis, my training is much easier. It became a much easier situation for us to manage.
So how many tools in this general area of performance monitoring or visibility, how many tools do you use now today?
Today we have four. So basically I would call the New Relic suite the whole tool, one tool set. Even though we're doing multiple functions with it, we also have our log monitoring, plus we have some external load testing and uptime monitoring that we leverage in there. Plus some services we have to actually leverage CloudWatch because that's the only one that's available to monitor some of them. So that would be probably the 4 primary tools that we leverage today for monitor everything.
Do you integrate them together or use them independently? Is it different people using each tool set? Or?
So they're pretty much integrated together. We try to instrument everything out there with those same tools. So anything we push out there, they're at least, well, except for CloudWatch, only when we're using a platform that we can't monitor one of the other tools. Everything else gets fully pushed out with all those agents and tools fully integrated from the start. So we try to keep it as similar as possible, even through our lower environments and upper environments.
So let's move to one of your specific migrations. I think you mentioned to me the Adobe Experience Manager migration. Could you talk a little bit about that and what your experience was during that migration?
Okay. Yeah, our Adobe Experience Manager is our primary content management platform. That's what we use to host all of our public websites. Those websites on a daily basis are hosting about 50 million visitors. So we have a lot of challenges with scale. You know, if we're trying to serve 50 million people a day, that's not page views, that's individual people just coming to see our sites. We have to make sure that platform is up all the time, highly available, and serving each and every user out there. If it's not, we're losing revenue. So that was the primary challenge for us initially. And that platform is designed in a very, I won't call it, it's not cloud friendly. We'll call it a monolithic platform. And basically it takes a lot of challenge to get it up there. When we first launched to the cloud, it took us about 2 to 3 weeks to build out a full production environment of this platform for one of our production sites. Today, we've actually leveraged automation and scaling and cloud practices where we stand them up in about 20 minutes. And if you saw one of these environments, you would be fairly impressed with that because we've done some pretty amazing things with it. The automation and scaling we put in place is pretty impressive, and kudos to my team.
Is that automated deployment processes as well?
Automated deployments in there, automated provisioning of all the hardware, automated standing up of all the supporting services behind it with AWS, the DNS entries, everything is fully automated. So our developers, you know, now when they need an environment to build a new feature, they just click a button basically and they get an environment 20 minutes later, where before it used to be weeks for them. So vast improvement for us.
So I don't remember if we talked about this ahead of time, but do your development teams follow DevOps processes?
They do.
Okay. And so do you support for operational issues comes back directly to the development teams as well?
Not 100%.
Not 100%, okay.
Yeah, it depends on the business unit. So
Right,
I will say it's different for each business unit in the company.
Okay.
But the majority of them do come back to the teams. That is who, we do have a frontline support operations team that does 24/7 monitoring.
Got it, yeah,
They will escalate it to those DevOps teams after a certain level. But
Okay.
yeah, most teams are fully involved. They do own their applications cradle to grave. But we do have some that are still stragglers that haven't quite got there yet.
Yeah, there's always some of those
Yeah.
out there, yeah. So are they watching daily the charts and knowing where their applications are performing and follow it, or are at least the leading?
The leading ones are absolutely following their metrics and getting that feedback and trying to drive that improvement. You know, their whole goal is, you know, once you get to that DevOps model and you're involving the development team in that 24-hour call, their whole goal at that point is, I don't want to be called at 3 a.m. So
Right.
they're very engaged at trying to make sure that the application is more reliable and available.
So I imagine, you know, of a lot of companies in your space, it used to be that your websites were just basic content, but you're turning more and more towards online video and video streaming, video on demand, and I'm assuming you're following that model as well too.
Absolutely.
So tell me how streaming has changed the way your applications and your use of the cloud.
So streaming has become our biggest data consumer over the last 3 years. It literally drives our content distribution network. So our CDN platform selection is actually absolutely driven by that video because we are serving so much of it. We have teams in place that develop applications for all of the emerging platforms now that support live streams being played from all of our networks. Our social side of the house is actually, at last count that I saw, we're actually serving 2.5 billion video views a month on Facebook. So, I mean, that's no small number. Our challenge becomes with that is, how do you monetize that? Because
Right.
there's very big challenges with that, but we're working through them. And I think
How do you
we're still,
monetize that?
yeah, that's the
That's
million dollar
another
question.
Yeah, that's another conference, another spot. But,
Yeah, absolutely.
so what do you do to give yourself visibility into your video streaming then, specifically?
So we've instrumented all of our video productions. So it starts in our in-house. So we're expanding that. Our initial deployment was with New Relic's agents. So we have New Relic on there. We've deployed New Relic browser, and plus we're pushing all this data into Insights, and we built out dashboards to actually monitor it, because we want to know what those end users are actually doing. You know, if they push play, we want to know that they had a successful watch of that video. We want to know if they push play and nothing happened. You know, that's the only way we can digest and fix those problems. You know, your end user monitoring at that point is very critical, because it's all being digested across cellular networks, across your Wi-Fi, because your cable networks, and depending on your provider, some of that problem is not yours, but you don't know that unless you're actually monitoring and instrumenting for it.
So you heard me talk about scaling and how scaling for your biggest day. Your biggest day isn't Black Friday, it's something else. But
it's the day before.
It's the day before Black Friday. Okay.
Our biggest day is actually Thanksgiving Day for our Food Network team. That's when everybody out there is trying to figure out what recipe they're going to cook. It's Thanksgiving is the day before.
Didn't even think of that.
We are actually hosting that week of Thanksgiving. We will average 30 million on just Food Network a day, visitors, and then the cooking channels will add another 15 to 20 million to that a day.
Of streams.
Of web pages and streams.
Okay,
So I'm just talking about unique visitors.
Got it.
Yeah, I don't know how many streams they're getting there. So we're probably talking about 50 million plus just to see food content.
Wow.
Recipe.
So how does that compare to a low day or a low time? What's the dynamic variation
Food Network runs about 12 to 15 million. So I mean, it's more than double.
Okay.
And that's just on Food Network. And then when we double the other networks and they're served out of the same infrastructure, it becomes much more challenging for us. So we have to react to that pretty aggressively.
So, obviously you know about Thanksgiving when it's coming. You know it's going to be a big day. Do you have spikes that are unknown?
So we end up with spikes sometimes that get caused by our talent. They will throw a URL out there when they're talking during the show, and everybody goes to that URL, and we get hit with it.
Okay.
So we try to adapt for that as well.
So how do you scale for those days? Do you have to know they're coming up and scale ahead of time, or do you dynamically scale? How do you make those days work?
So in the past, we used to have to know that. We would absolutely fail. Our hardware would fall on its face. But since we've made our modifications and moved into the cloud, with our scaling and elasticity we have in place, we have not had, I'm going to find some wood to knock on, we have not had that problem in 3 or 4 years.
And is that, so which specific technologies are giving you that dynamic capability? Is it auto-scaling in EC2, or is it more Lambda? What are you using that allows you to get that dynamic
So it's the scaling in EC2, plus it's the whole overall architecture design where we put it in there. We actually leverage our CDNs a little bit more. What things we didn't traditionally cache, we actually cache now. When people used to tell us you couldn't cache that, we found out you can cache that, and you should cache that. If you're serving millions of people, you absolutely should cache everything out there. Everything you're serving should be cached, because you can survive if you are. So it's just a matter of architecture changes we put in place. And monitoring is critical for all of this. We want to monitor everything that we do and make sure that it's instrumented well enough that we can react and find what is wrong and hopefully proactively change things to prevent our application from falling down.
Okay. So talk a little bit about serverless and Lambda and things like that. You're using them in a little bit in a couple of key areas.
We're using it in a lot of areas now.
Okay,
I mean, it's actually growing pretty rapidly. It's becoming one of our developers' favorite tools.
In production?
In production. Our In the Kitchen app is probably the biggest place we leverage it in production right now. Most people that have used that application, that is all being served by a combination of API Gateway, Lambda, and DynamoDB on the back end for most of the application performance. Other app areas that we're using it, we actually leverage it for monitoring. We use it for backups. We have cloud cleanup activities, because you're constantly trying to battle cloud sprawl. As you grow bigger, that becomes much more difficult. So we have Lambda functions out there that are actually monitoring policies that are generated by either AWS or some other policies that we've put in place, so that those Lambda functions fire and they'll clean up, extra EBS volumes and stuff like that. Elastic IPs that have been orphaned. So we have all of that in place.
So are your Lambda functions scripts for specific actions? Are you building full services with them, or?
Full services in certain areas, like in the kitchen, we have, it is it's full application with full services on the back end.
Okay.
On our mobile, well, not mobile platform, our sweepstakes platform, we're actually using it a lot for the event processing. Anytime an entry is done, a Lambda function will fire off that does ETL transformations and stores the data wherever it needs to go.
Okay. So. And what's your biggest challenge with monitoring those?
So, because they are a completely different animal, you can't put an agent on there.
Right.
You can't get exposure to the data. You are relying on AWS and other sources to make sure that works for you. But you really want to know that that's working. So we've actually put in place. We have New Relic monitoring most of our Lambda functions. There are still big challenges with that. I mean, we don't have an easy way to show our customers what their functions cost. I get an AWS or a Lambda bill now, but I can't break it out by cost. So, but that's to be expected. There are growing pains with the platform, and I expect it to move forward and improve as we go.
Okay. Well, thank you very much.
Thank you.
Mark. I'd like to mention a couple of things. We are, stop by our booth. You're going to be at our booth, I think, as well, coming up. Do you do a session at the booth? I don't remember.
No,
okay. But that's booth 2412 over in the main hall. And I want to thank everyone for coming.